Chapter 12. Chapter 12 deals with experimental design. Guys, stop talking. Chapter 12 deals with experimental design. Okay, we just designed an experiment to test if caffeine affects our heart rate, right? That was an experiment because we were imposing a treatment upon our subjects, you being the subjects. Okay. Now, an observational study is a study in which you're not manipulating any factors. We're just seeing what happened with SAT scores after the pandemic, and we're just observing those changes or those values. A prospective study observes into the future. You agree to be a part of the study, and I follow you for several years of your life, and then we see what happens. Okay? There are prospective studies. They typically focus on estimating differences amongst groups that appear as they are followed. A retrospective study is where you look at previous conditions or behaviors. It usually focuses on estimating differences between groups or associations between variables and looking into the past. An experiment manipulates factor levels, creates treatments, randomly assigns subjects. Okay, so you'll have to be able to determine the difference between observational study and an experiment. A factor is a variable whose levels are controlled by the experimenter. So for us, the factor was the caffeine. Okay? We controlled how much caffeine you got. Oops. The response is the variable whose values are compared. So our response is what? What was our response in our experiment? Our heart rate, right? Was our heart rate, did it respond to the caffeine? Forgot. Okay, this is a lot of vocabulary. Okay, so that's why I usually print these out for you. I will print them out and have them for you tomorrow. Okay. The experimental units are the individuals on whom an experiment is performed, usually called subjects. They're called participants when they're human. You were my participants. You were my experimental units. The experimental units might be tomatoes. Experimental units might be strawberry plants. The level or the specific values that the experimenter focuses or chooses for the factor. So how many levels of our factor, caffeine, did we have?
How many what?
Levels did we have of our caffeine? We had 2, right? We had caffeine or no caffeine, right? Some or 0. Now, if I had an intermediate soda that had like half the caffeine as Diet Coke, then we would maybe have 3 levels. Our treatment was the caffeine, was the giving you the soda. It's a controlled circumstance. Okay. Now, ultimately, we want to see or determine if there is a statistically significant difference between the change in heart rate for those that got caffeine and those that did not get caffeine. Is that difference significant enough for us to believe that we caused it with the caffeine? Or do we think that that difference is just normal variation in your heart rate over a 20-minute span? The control group, who was our control group? The control group is the group that gets the placebo, right? We do nothing to that group or we impose a placebo. If you're talking about strawberry plants, you don't have to have a placebo for strawberry plants because they generally don't have a placebo effect. They're not going to grow better because they think they got fertilizer. Okay? So you don't need a placebo, but it's still a control group if you don't give them any of the fertilizer. We need to have control groups so we have a basis for comparison. If we don't have a control group, we don't know whether it was time that caused the strawberries to grow better or if it was the fertilizer. So we need to see how much the strawberries are going to grow without the fertilizer and then how much they're going to grow with it. Oh, wait, hold on. Now we did some blinding in our experiment. You did not know whether you got caffeine or caffeine-free. Grayson and I know which one it is. Okay, we will tell you after we measure your heart rates, we'll let you know. Okay. No, we never mixed. But that would be like a third, right? What if we give half the amount of caffeine? We do half regular and half caffeine free.
Did half caffeine and half one of the same cup?
That would be a third treatment.
Oh, what's the point?
Yeah. So our experiment was single blind because we didn't have an outside person measuring your heart rate that didn't know the treatment. You were measuring your own heart rate. If I were doing an experiment on strawberries and the person who is evaluating the strawberries doesn't know whether they got the fertilizer or not, that's double blind. Okay? If someone is evaluating a patient for depression and you're giving depression medication to see if it works, your subject, the person taking the medication, is blinded, and the person evaluating their depression symptoms is blinded. That way, the person evaluating doesn't inadvertently believe that you got better just because they know you took the medication. Okay. And then the placebo was the null treatment, also known as a sugar pill. And the placebo effect is that tendency to show a response just because you are in the experiment. Right? And that's why we have to have that control group to compare with. Then we had blocking. We blocked you based on initial heart rate, right? And we actually did a matching, groups of 2. We had 2 treatments, and so our blocks were of size 2. So we grouped you based on your initial heart rate, right? The 2 lowest heart rates, the next 2 lowest, and so on. If you, say, bought strawberry plants from 2 different stores, you might want to block because maybe the source of those strawberry plants is going to affect how they grow. Do plants from Home Depot grow better than plants from Lowe's? I don't know. I can't keep a plant alive to save my life. I can't even keep a succulent alive. That is how bad I am.
Are you a plant killer like my mom?
Yes.
Oh my.
I can kill a succulent. Like, you don't have to water them very much, but I have managed to kill them.
That's crazy.
So
My mom's killed an aloe plant.
I don't even try anymore. I like my plants from Big Lots. They don't need water. They don't have dirt.
Supposed to get flowers, and I said, no, just kill them.
So we have 2 types. Our designs are completely randomized. That would be if we just randomly assigned you to either group A or B, or a randomized block design. We did a block design because we grouped you based on your initial heart rate. And then we randomly assigned within our blocks. Now, a confounding variable or factor is when one factor is associated with levels of another factor. For example, the reason we had to use Diet Coke and Diet Caffeine-Free Coke is because sugar could be a confounding variable with the caffeine if I used regular Coke and Diet Caffeine-Free Coke. We wouldn't know whether it was the sugar content or the caffeine. We had to redo our heart rate this morning because we ingested a ridiculously stupid amount of candy last night, so maybe that is still in our system, raising our heart rate. Who knows, right? Better have a new baseline today than use the one from Friday. I know yours was lower. So there's 2 things, lurking variables and confounding variables. Lurking variables are what cause there to seem to be an association. Ice cream sales and drowning. As ice cream sales increase, so does drowning. So you better not eat ice cream, you might drown. Or maybe it's just a lurking variable of summer, right? And in the summer, ice cream sales increase, and in the summer, the drownings increase because people are swimming, and so that's why they seem to have an association. That's a lurking variable. Confounding is when the response we see in an experiment is partially, or at least partially, attributed to something that we didn't control. And when that happens, our experiment is usually invalid. If we can't tell the difference of whether it was sugar or caffeine, then how can we make any conclusions from that? Okay, so let's look at our results. when I average the difference, okay, when I average the change in our heart rates for group A, which was the caffeine-free, right? Yes, caffeine-free was group A. Let's write that down so I can not keep forgetting. Okay. It went up 0.08 on average beats per minute. The caffeine group had an average change of going down 5.57 beats per minute. Okay.
Whoever went down 19.
Who had a starting heart rate of 111?
Oh, that's not bad. I'm surprised that wasn't me.
Okay, so is that difference? Okay, so again, what second semester is all about is, yes, we saw a difference, right? It's not what we expected. We didn't expect the group that got caffeine to actually have lower average heart rate, right? A difference of it going down. But is that difference significant enough to say, well, caffeine made our heart rate go lower, right? Was it really the caffeine or was it other factors? And that's what we deal with second semester. We can tell there's a difference, right? Obviously, it's almost 5.5, 5.6. But is that significant enough for us to believe we caused it with our treatment? Okay, or is it different from the standard that is stated for us? And those are hypothesis tests that we will deal with. This particular one would be chapter 23, I believe, because it would have been chapter 24. So we talked about the four. Hold on. So our 4 principles of experimental design are control. We control as many sources of variation other than the factors we are testing for. We need to randomize, which is going to allow us to equalize the effects for unknown or uncontrollable sources of variation. We can control our tolerance to caffeine. We couldn't control how much sugar we ate last night, how much sleep we got last night. Those are things that we realistically could not control for our experiment. So, time's up. Hold on. Okay, so our third principle of experimental design is replication. Not only does that mean sometimes the experiment needs to be repeated, but we need to have more than just 1 strawberry plant or 2 strawberry plants. We need to have a multiple subjects in our experiments. And then the fourth is blocking. If it is necessary, we want to block for factors that we cannot control. We block for age, we can block for gender, we can block for initial heart rate. We maybe could have blocked for people that regularly drink caffeine as opposed to people that do not regularly drink caffeine, but it didn't seem like most of you raised your hand and said you don't have a regular caffeine regimen, which is good, which is surprising. Okay, our OptiGrow experiment is actually on page 321. Okay. An ad for OptiGrow plant fertilizer claims that with this product you will grow juicier and tastier tomatoes. You'd like to test this claim, and you also wonder why might it be able to get half the specified dose? Like if I used half the dose it says and I can stretch that bottle longer, will I still get juicier and tastier tomatoes? So how are we going to set up an experiment for this? Okay. So we need to think through what we need. What do we need for this experiment? Tomatoes, right? Can we just use 2 tomato plants? No, we want replication, right? So replication is part of what we need to do a proper experiment. So how about 12 tomato plants? Does that sound like a good amount of plants? So let's take 12 tomato plants. Okay. What are things that you will need to control about growing these tomato plants? Okay, water, soil, sunlight, shade. So we want to make sure we're planting them in the same soil. We want to make sure we're planting them in an area that's going to get equal sunlight the whole time. Like the ones we're not giving fertilizer shouldn't be in the shade while the other ones are in the sun, right? We need to make sure they're getting an equal amount of water daily. What other things might we need to control? So these are control factors. Okay, so if we're going to plant them from seeds, right, how many seeds we plant in each one, or if we're like getting the like already sprouted plant, right? So whether it's seeds or sprouted plants. How far apart they are. Okay. So what are our treatments? The OptiGrow, right? What are the levels of our treatment? Well, we want a full dose, right? Half dose. And we should have a control group, right? A no dose, right? We should see how the plants grow without any fertilizer. We want to know if a half dose will do the job or the full dose. Okay? So those are our treatments and our levels. The treatment is also the factor. So there's one factor in this. Okay? We're controlling all these other things. We're giving them all the same amount of water. We're planting them in the same soil. We're planting them in the same spot. They're either inside a greenhouse, right, where all the conditions are controlled, or they're outside in a plot that gets equal sunlight, right? If one plant is going to get more shade, that might affect that plant more. So, and then we need to randomly assign, okay? We have 12 plants and 3 levels. How many plants are going to go into each group? 4 plants, okay? So we take our 12 plants and we randomly assign them. We can say randomly assign to our treatments of the full dose, the half dose, or no dose, which is our control. Okay. Then after time, what do we need to do? Right, we want to evaluate their juiciness and tastiness. Because that's what the commercial says, how well they taste. So we need to compare the taste and the juiciness, right? No, gross. We're going to taste all 12 of the plants. We're going to take a tomato off of each of the plants and evaluate their taste and juiciness. Now, where would blinding come into play here?
Not knowing which is which, right?
Who needs to blind? Who needs to be blinded? Did the tomato plants need to be blinded? No. The tasters, right? So the taste and juicy detectors, right? So the evaluators need to be blinded, which means there's a second person that knows what treatment each plant got, right? So the plants are labeled 1 through 12. That person knows, but the person who's tasting them and rating them for juiciness and tastiness is not aware of what treatment they got, so that they aren't affected by the experiment. Okay, so that's completely randomized. But what if I wanted to, this is completely randomized with 3 levels, right? 1 factor, 3 levels. What if I wanted to see how the amount of water affected it as well? What if I wanted to do not only the fertilizer, but I wanted to test the amount of water we give them every day. So I would get more, like I could do like a cup of water a day or a half a cup of water a day, right? That's, we could do 2 levels of water. So let's look at, what if our treatments are now the OptiGrow and water. The OptiGrow levels are full, half, and none. What levels do we want the water to be?
Water 2 times a day, 1 time a day, and then.
Okay, once a day, twice a day, and let the elements, right? So let's do once a day and twice a day. We'll talk about how we will set up that experiment with, this has a total of 3 times 2, 6 different groups, right? Because I'm going to have to do full fertilizer once a day, half a day, half fertilizer once a day, twice a day, and then no fertilizer once a day, half a day. Doesn't that make 6 groups? Yes, the 3 levels times the 2 levels gives me 6 groups. So how many plants are going to go into each group now? 2, right? 2 of my 12 plants. So I have my 12 tomato plants. I'll go once a day, water, twice a day water, and then you have once a day full, once a day half, once a day none, twice a day full, twice a day half, and twice a day none. Okay, and then we are randomly assigning to those 6 groups. Okay, so we randomly assign 2 plants to each of the 6 groups. And then after a while, what do? This is the part that everybody forgets to say, what are we doing at the end of the experiment? We're comparing them. What are we comparing? Still comparing juiciness and tastiness. Okay.
You wouldn't include anything about the water in our comparison?
Well, so what we're measuring at the end is juiciness and tastiness, right? And then we'll know, like, oh, the twice a day no fertilizer was the juiciest, or the twice a day full fertilizer was the juiciest. So because we have them divided into those 6 groups, then we'll look at, right, comparing which group was the juiciest and the tastiest tomatoes. Okay.